Good morning. We use the equivalent circuit of this circuit to solve this problem. We calculate the equivalent circuit, then we calculated the current I1, which is here. Once we had I1, we calculated I6 and I5 using the current divider, and then we calculated the drop here and a voltage drop, and then we calculated I2, and this node we applied the Kirchhoff's law, we calculated I3, and using the current Kirchhoff's law we then calculated I4. But here we are going to apply the mesh analysis to calculate the currents. First of all, we have to choose arbitrary 3 mesh currents. Let's take this mesh and let's call this one I1, like this one. Here we will call it, these are arbitrarily, we can use the other directions. Let's call it I3, let's call this one I5, and let's write the Kirchhoff's voltage law that states the algebraic sum of the individual potential differences across each circuit element in a loop or a mesh of circuit is equal to the algebraic sum of the EMFs acting in that loop or mesh. On applying the voltage law, we obtain for mesh, for example, let's call it X, A, B, D, Y, X, and we can write, for example, because we have chosen this current, the voltage drop here on this resistance will be in this direction, because this arrow will show because the current flows from the highest potential to the lowest. So in red I will draw voltage drop VR2 here, VR1 here, and here VR6 because of the current that flows like this, so the drop will be in this direction. But for this current, the drop will be in this direction, so it's in green, and here it will be green. So in the first mesh we can write that V, because we are entering a minus and coming out from plus, we write plus V. Here we're going from plus to minus, we write minus. I will write it, let's try and put it in green as well, because it will be positive. Here it will be positive, we write V. In red it will be minus VR1, this is due to I1, minus VR2, let's change this one, minus VR2 due to I1, minus VR6 due to I1. And then we can add, these are positive, the green one, so we can say plus VR2 due to I3 plus VR6 due to I5. This is equal to 0. We can do the same thing in this mesh. Let's, in red, we will show how the drop will be. Here it will be in this direction, VR4. Here it will be in this direction, VR3. And here it will be in this direction, and we call it VR2. And now the drop due to I1, because I1 is flowing this way, though the drop is this way. And here, because the current is flowing, the drop is this way. So let's write. Here we will have, in green, we will have VR2 due to I1, okay, minus VR2 due to I3 minus VR3 due to I3 minus VR4 due to I3 is equal to 0. Okay. Did I forget something? I forgot something. It means that we forgot this drop that is due to I5, and this is in this direction, plus VR4 due to I6 is equal to 0. This is this mesh that is AC, BA. This is C. Okay, let's write now for this mesh BCDB. So let's take all this so that we will write again the drops here in red. So because the current is flowing this way, VR4 is this way, VR5 is this way due to I5, and VR6 is this way. So we can write VR4 there, VR4 there. So we can write minus VR4 due to I5 minus VR5 due to I5 minus VR6 due to I5. Now we see the drop here due to this current is in green, so it will be positive, plus VR6 due to I1, and here the drop will be this way because the current is flowing this way, so the drop is this way. So we can write VR4 due to I3 equals 0. So let's now write them differently. So I can write them here again. So we will have 3 equations and 3 unknowns that we can solve. So this is, we can write it like this. V is equal to R1 plus R2 plus 6 times I1, okay, minus R2 I3 minus R6 I5. Second one is, second mesh 0 is equal to, this is I3, this is R2 plus R3 plus I4 times I3 minus R4 I5 minus R2 I1. This is second equation. Third equation is the current I5. Here we have plus R4 plus R5 plus R6 times I5 minus R6 I1 minus R4 I3. So we have a system of three equations and three unknowns that we can solve. Let's write numerically the values of these resistances. We will have 250 is equal to 50 plus 180 plus 150, or I'll give the result of the result here. It's 380 I1 minus 180 I3 minus 150 I5. 0 is equal to minus 180 I1 plus 180 and 10 I3 minus 270 I5. Here we will have minus 150 I1 minus 270 I3 plus 580 I5. Here we can use the Kramer rule method, and we can calculate the determinant of this equation. D is equal to 380, 180, 150, 180, 810 minus 270 minus 150 minus 270 and 580, and then we can calculate. Do I have a space here? Let's take this one again. I will write them again, these equations. 250 0, so that I remember all this. 380 minus 180, 150 I1 minus 180 I3 plus 110 I3 minus 270 I3 and minus 150 I5 minus 270 I5 plus 580 I5. So we calculated the determinant here. D is equal to 380, 180, 150, 180 plus 810, 270, 150 minus 270 and 580. This is D. D1 will be 250 0 0 minus 180, 810 minus 270 minus 150, 270, 580. This is D1. D2 is equal to 380 minus 180, 150. Here the 250 0 0 minus 150 minus 270, 580. I3 will be equal to 380 minus 180, 150, minus 180, 810, 270, here 250, 0, 0. So we can calculate I1 is D1 over D, I3 is D2 over D, and I5 is D3 over D. So we can calculate this way, but we can simplify because we had made a delta star transformation, so we can use that to write again the equations differently, so that it will be, we will have two equations and two unknowns. We have calculated previously the equivalent resistance R2 prime, R3 prime and R4 prime, so we can write the new equations. We have two meshes, I1 and this mesh 1 and 2. So we write the first one, 250 is equal to R1 plus R2 R4 prime plus R3 prime plus R6 times I1 minus R3 prime plus R6 I5. Second loop, 0 is equal to here minus R6 plus R3 prime times I1 plus the sum of this resistances R2 prime plus R3 prime plus R5 plus R6 times I5. So the numerical values, we will have 250 is equal to 340 I1 minus 210 I5. Here we'll have 0 is equal to minus 210 plus 490 I5. From here we can calculate the current I1. Del D we can calculate it, 304A minus 210 minus 210, 490, that gives us calculator 340 times 990 minus 210 times 210. Is it right? Let's write it down. I'm not sure about the result. 500. Now D1 is equal to 250, 0 minus 210, 490, will give us 250 times 990. This gives us 500, and we see that I1 is equal to D1 over D, and it's 1 amp. We find the result we looked for. Now remember the result of with the method of the equivalent resistance, we had 1 amp, and now we can calculate D2. D2 will be 340 minus 210, and here we have 250 and 0. The result is plus 250 times 210